Hello followers, this is going to be another teardown video. What we have here is a Sharp MZ-80K. This is an 8-bit computer from the late 70s and early 80s. This actually was our first family computer. So this has come out of storage from my parents' place because they were having a clear out. And it's basically been in a box for a very, very long time, and I've picked it up and I thought it'd be interesting to have a look at a little bit of the history of this this computer, both personally and from a computing point of view. We'll open it up, have a look inside, and see what it's like. There may also be a fault on it, as I seem to recall the last time we used this, which would have been a very, very long time ago, it really stank of ozone, which usually means there might be a fault on the CRT high voltage transformer. So I'll have to have a look at that when I open it up. Right, so the basic specification of this, it is, as you could probably guess, it's a Z80 CPU. It's not actually a Zilog CPU, it's Sharp's own clone of the Z80. They came shipped with 20K of RAM, but that was upgradable, and in fact I think most of the MZ-80Ks that were shipped or actually sold had the memory expanded to the full 48K. This was often done by the reseller at the point of sale, so I think most of them shipped out of the factory with 20K, but they all ended up with 48 by the time the users actually got their hands on them. So that's 48K of RAM. The CPU runs at 2 MHz, and as you can see, there's a keyboard built in. Everything is a complete self-contained unit. We've got a little 10-inch monochrome CRT in there. That is a white display, not green, which was nice. We also have a cassette for loading programs. There was optional extras for disk drives and that sort of thing, but we never had that. Literally all we had was the actual unit and no other peripherals. Interestingly, the keyboard is a bit of a funny layout. Although it is a QWERTY keyboard, they are actually in lines, so it's not quite so easy to type on it. And of course, you got a space, and the enter carriage return key is here, not up around here somewhere. So the retail price for one of these would have been around about £475, £500 back in 1981-ish. I'm not sure when we actually bought this one or how much we paid for it, but I guess it would have been around that sort of mark, which is not an insignificant amount of money. If you compare that to things like the ZX80 and the ZX81 at the time, which were far cheaper than something like this, but this was a lot more of a professional kind of thing. But in a way, I guess the cheaper stuff like the Spectrum as came later, but the ZX80 and 81. They really sort of stole the market because they were just so cheap, and everybody bought one, and unfortunately we stuck with the Sharp with this until we moved to an IBM PC compatible. We started off with an 8088, and then we moved up to a 286 after that. So as you can probably tell from looking at this, that it's a pretty well built unit. It's all steel construction. It's not light. It weighs about 13 kilos. Around the side here, we've got a small speaker. It did have sort of primitive music and sound options, things you can play with. Around the back, it's all pretty simple. Power switch, power inlet, and there is an expansion port on the back here, which just gives you direct access to the bus. So as I mentioned earlier, we actually bought this as a family computer, but primarily it was actually used for my father's business, and there was various programs that he wrote on this to help with working out costs and prices of certain products and things like that. So it was really used more for as a business tool rather than a toy for us kids to play on. Although we did use it a fair bit. We played a few games and wrote some basic programs and cut our teeth in the early days of IT back then, which was kind of nice. It sort of set me on a path into being a bit of a geek. So along with this, I also found the original software tapes, and we've obviously bought some third-party software. Some of those are actually written in BASIC, and some of them are actual binary machine code programs. There's probably a few games and things in here. I don't remember buying any business software. I think we just wrote everything that was needed in BASIC. So you actually have BASIC on tape because the built-in ROM is a very, very simple thing. It's called the monitor, and you can't really do anything with it other than command it to load something off tape. So you'd either load a machine code program off tape, or you would load in BASIC from tape and then load in the BASIC programs after you've loaded BASIC. So the tapes we've got here, these are obviously cassettes that we've bought and put software on. Space Invaders from Highlight Software, whoever they are. Composer, I wonder whether that's some kind of music program. Right, so I think what we'll do now, we'll just take the top off this and have a look on the inside. I wouldn't expect it to be particularly complicated. I do have some recollection of being in there before, and I've got some memories of what where bits are and things like that. So we'll just open it up again and have a quick look inside. So to actually get inside one of these, if you just tip up, there's 4 screws. 2 down here and 2 up at the top. They're just off camera. A nice bit of quality engineering. We've got nice screws with captive washers and a captive spring washer as well. So take these out and you don't lose any of the washers or anything. Very nice. Right, so the really neat thing about this this computer for servicing is this folds up and you have a stand and a nice little screw here to lock it in place so you can't accidentally have it fall on your head. Now it's going to be a bit awkward for me to film in this because it is a bit dark and all the monitor of course is hung above it, so it's going to be a bit tricky to get some light in here so you can actually see. Right, I've just positioned a torch so it reflects off the top here. Hopefully it should make it a little bit easier for you to see what's going on. So we have, we've got a big transformer over in the back corner. The mains input comes in, doesn't seem to go through any filtering or anything, straight into here. This is quite clearly the power supply. We have 4 wires coming out of there. They are actually labelled. So we've got plus 12 volts, plus 5 volts, ground and -5. Right, so if we take a little bit of a closer look, we have quite clearly the RAM just here. We've got 3 banks. We've got RAM 1, RAM 2 and RAM 3. Now looking at this, the first bank is loaded with Sharp LH4116-3 memory chips. Now they're Sharp branded, but these 2 banks on 2 and 3 are branded ITT, and they are 8021E. So it sounds like that theory that most of them shipped out with 20K, and they were upgraded after they were shipped is probably true, because if these were all installed from the factory, you'd expect them all to be the same. Given that these have different ones in this bank, that's probably been upgraded. And typical of computers of this age, we've got a load of 7.4 LS logic around here. We have a couple of ICs. We have a Texas Instruments SN74150N. This one here is an SN74154N. We have, that looks like a custom part. Just trying to read the legend. And that one says M-ROM. So that's obviously a mask ROM. So that might be the character map in there. We've got a few solderable jumper links here, and here as well, with two. Those jumper links look slightly different to all of the other ones, so that could well be jumper options to indicate that it's got the 2 extra banks of memory. So working our way backwards, we have, you can see the big power rails, again all labelled. We've got a whole load of decoupling capacitors across here. In fact, there is quite a lot of decoupling all over, to be honest. And going a bit further back, we have the CPU, which is labelled LH0080, and it also says Z80 CPU. That pretty much gives that away. A bit further back, we have a Texas Instruments SN74100N. So these are probably all from the same range of ICs, probably doing various housekeeping stuff. We have an EPROM in a socket. That is a TMW323D, and I might pop that out actually and see if I can read what's on there. I might even reburn it as well, because after this amount of time that might actually be starting to lose its memory, which EPROMs do over time. It does take a very, very long time for it to happen, but the way EPROMs work is they essentially store a charge of energy in each of the bit cells to indicate 1 or 0. Now over time that charge slowly leaks away. Eventually they will just effectively be blank. On something of this age, which is now getting close to 35 years old, it's probably worth reburning that. All you have to do is just read it out and then just write it back in, and it's all ready to carry on for another load of years. Right, heading further back, the dark section. We've got more 7.4 series. We've got another device at the back here. Having a job to read what that one says. That's an NEC branded D8253C-5, and next to that, under this connector here, we have another NEC branded chip, which is a D8255AC-5. And we've got a little bit of analog stuff at the back here. This connector here runs up to the cassette drive. These two at the back run to the... Oh, sorry, no, that one runs to the keyboard. This one runs to the cassette, and this one runs to the CRT. Right, so if we just have a look underneath the lid, right at the front here we have the PCB for the keyboard. So that just runs over to soldered wires here, and that just runs down to the main board, We have a small little board over the side here. That's just got an LED on it. I do recall that being a bicolour LED, which was quite cool. I remember seeing that for the first time, thinking it was amazing. You know, I mean, LEDs were pretty cool anyway, but to have one that was 2 colours, it's amazing. So right at the back here, we have the tape drive. So that's just mounted in, just in a hole that's been stamped out of the metal cover. It looks a pretty simple, simple device, which it would be. Belt there, still feels fairly tight, that, so it could well work. And just at the on the other side of that, we have the underneath of the circuit board for the CRT with a whole load of pots for adjustment. We've got volume, contrast, brightness, focus, vertical hold and horizontal hold. So that's all adjustable. Yeah, I seem to remember that it was all... I couldn't quite understand why the volume control was actually inside of the... inside. It meant it was really difficult to get to if it was too loud. So quite clearly there's no other wires connecting the CRT to the power supply. So all the power for the CRT actually comes through the motherboard through this cable. I would imagine that's running on 12 volts. That's probably what the 12 volt feed is for, that and the tape drive as well. Right, I've just turned it round so I can take the cover off the CRT off, so I can have a quick look at the CRT driver board and see if I can see anything untoward, and that might explain why it stank of ozone the last time we saw it. So I've actually removed the screws already, so I'm just going to lift the cover off. Okay, so now we've got the cover off, we can see the parts of the CRT. We've got the actual pitch tube here, we've got the deflection coils, connections to the actual tube. We can see here the high voltage connection from the flyback transformer just here. We have also on the side here this speaker. That is actually a Sharp branded speaker as well. The tube is a Sharp branded tube as well. It's all very, very dusty, which is not normally particularly great for high voltage. So I can't see anything obvious. There is a patch of what looks like something that's wet just in here. So I wonder, maybe one of these capacitors has leaked. But I can't see any obvious tracking or anything on the flyback transformer. I can't really see anything particular untoward apart from that wet patch. Right, so I think what I'm going to do is just try and clean this up a little bit and see if I can figure out where this little wet patch is actually coming from. I'm just going to clean it up, get all the dust off, because that's sometimes when things start tracking, you get an arc across and it carbonises the dust and then creates an easier route. So the first thing I'm going to do actually is just make sure that there isn't any charge on the tube, because these have connect like a high voltage capacitor in a way, so when the machine's switched off it can store a charge on the tube, and if you start taking off the high voltage connector, you can suddenly find yourself getting zapped. So you just have to short out the terminal in there to ground and you're safe. Well, I've had a good look round the circuit board on the CRT. Couldn't really see anything particularly wrong with it. So what I'm going to do is now I've cleaned up. I've cleaned a lot of the dust and stuff off it. What I'm going to do is power this up. I'm just going to disconnect the power supply because what I want to do is just check the voltages coming out of the power supply, make sure they're okay, and then I will plug that in and we'll see what happens. Right, so I'm just going to turn this on, and we're getting 19 volts on the 12 volt line. Wow, hang on. 19 volts on the 12 volt line, 12.6 volts on the 5 volt line, and -5 on the -5 volt line. So, I wonder whether something's a little bit iffy there. It's possibly a good idea not to turn this on with it all plugged up, because at this connector here it should be fully regulated. Okay, I've just taken out the power supply from the main chassis. It's held in with there's just 4 screws underneath on the base of the chassis. You just take those off and the whole power supply comes out as a complete unit. So that's pretty easy. So I'm just going to take the top off this. Right, let's see what we can see. I can see it doesn't look very good. These capacitors are all massively corroded. Yeah, I guess that's not going to help. This one here is all bulged and all deformed. You probably can't quite see it on camera, but it's all rippled, and there's a load of aluminium oxide on the top, proper crusty. And you could probably see on this capacitor as well, it's all rippled. That should be a nice flat. It's all strangely deformed. So it looks like the aluminium can is completely oxidized. Okay, what I've done, I've just unscrewed the actual PCB just so I can have a quick look underneath. And the PCB does look okay from this side, and there's all the tracks are really nice big chunky tracks, so that shouldn't be any problems if any of that corrosion has got down onto the underside of the PCB, because there should be plenty of copper there to solder things to. So I think the best course of action for this is just to replace all of these electrolytic capacitors, because they all look a bit dodgy in some way or other. Right, so a few days have gone by, and in that time I've removed all the old capacitors out of this power supply. That's one of the worst ones. You can see there how deformed it is. This is one of the better looking ones. I've ordered some new Nippon Chemi caps to go in as replacements. I've put those in, cleaned the board up, and I'm just about to turn it on and give it a quick test and see what it does. Hopefully it won't blow up. Interestingly, I have actually tested these old capacitors on my capacitance meter, and they all come out pretty much what they should be, if not a little bit over. I don't have an ESR meter, so maybe that would tell a different story, but they all seem to check out in terms of capacitance. And actually, looking around them, it doesn't look like any of them have actually leaked. So I was kind of wondering what might have actually caused this, and when I was taking the old caps out, I did notice there was a huge amount of flux everywhere on the board. It was absolutely covered in it, and I wonder whether it's actually the flux which has corroded the aluminium. It might have wicked underneath the heat shrink covering on the can, and that slowly corroded it. That might also be the reason why these two caps here, these actually broke off, leaving the legs in the PCB. And again, I wonder whether that could have been caused by the legs slowly being corroded away by the flux. So that is a definite possibility and a good reason to clean your PCBs. Right, so I'm going to switch this on see how it works out. If everything checks out, it will go back in the computer. I'll probably put some hot snot around some of these because a couple of them I didn't get the pitch quite right, so they're standing up a little bit, so I just need to pop a little bit of hot glue on there just to stop them wobbling around, and we should be good to go. Right, so I've just got my multimeter connected up. This should be on the 5-volt line, so I'll just switch this on. And yay, that looks better. 5.1, perfect. And if we check the 12 volt, 12.2, excellent. And the -5 is still -5, excellent. Right, this is all good to go back in once I've done a few little bits. Get the PCB screwed back down, and we'll give it a try and see if this thing works. Okay, I've got the power supply back mounted in the chassis, so I'm just about to power this up and see what happens. Probably might help if I plugged in the power supply. Well, that looks pretty good. Yeah, that looks pretty good, and I can't smell, hear or see anything untoward around the CRT either. It just seems to be completely normal. So I can't smell anything, no ozone or anything like that. So what that smell was 25 years ago, who knows? But I don't know. Okay, that all looks really good. There's nothing untoward. So what I'm going to do now is just put the covers back on, screw all this back together. Going to clean the cassette tape heads because they probably haven't been done. Give some a try. Fancy Space Invaders? Here we go. Oh, it's looking promising. Oh, denied. Should we give basic a try? Been going for, oh god, it must be 10 minutes, so there's no way that's, I'm forgetting that's obviously not working. Right, I've just tried a few of these different tapes, and a lot of, well, most of them just come back to the monitor. They don't actually do anything. I think that is because they are basic programs, and it just aborts out once it's loaded it in. So I've got one last machine code software to try. If that doesn't work, then I've got no tapes that actually I can load in. So, because everything else we've got is written in BASIC, and we need to load the BASIC interpreter before we can actually load any of the BASIC, and that doesn't work. So. Blimey. Oh, what? Why put the volume control inside? Why put it in there? Good grief. It's a bit loud. Stop the cassette. So we got dot and slash and space is speed, game start. S key. It's Pac-Man. What am I doing? Oh, right, okay. Oh. It's like a version of Pac-Man. Oh, that thing's coming to get me. Oh! Oh, that was a close one. Oh! Oh, you have to start again? You bastards. Oh! You git! Oh, oh, oh. Yeah, that was my fault, that one. Oh! 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 Awesome. Oh, there we go. High score. 310. Right, well that's I think that's pretty much the end of that. That's great that works, because it proves the cassette drive works and the whole system seems to be absolutely fine. I'm going to be popping this up on eBay to sell it, because it'd be nice to pass this on to somebody else who might appreciate it a bit more than we have, given it's been boxed away for 25 years. Right, I hope you found that bit of retro computing interesting. If you did, give it a thumbs up. If you're not subscribed, subscribe. There's going to be more like this and loads of other weird stuff. So, thanks for watching, everybody, and I'll see you on the next video. Catch you later.